And the title of the panel itself is focusing on how can we build usable infra for a trustless world. So this is, I think, a very hot topic nowadays with respect to focusing on usability. I'm very glad to have pioneers with us that are bringing very novel use case, still very young projects, but very ambitious with respect to the mission they try to achieve. So with that, I would like to ask you to just briefly introduce yourself, and then we can dive into the other aspects of the discussion. Maybe we can start with you, Orest, if you can briefly introduce yourself and T1 protocol.
Sure. My name is Orest. I'm a computer scientist, and we actually all share the same alma mater of the TUM in Munich. Woo! So very happy to be here. I have a background in computer science. I founded a non-crypto startup some 10 years ago, and another one a couple of years later, and then worked at Scroll, trying to bring scalability to the Ethereum ecosystem, and stemming or coming from this vision of using ZK for that, and then finding out, oh shit, liquidity gets fragmented, and ZK, no matter how much faster it becomes, will always be so much slower, by orders of magnitude slower than native compute. And this basically breaks this very cool feature of blockchains, which is composability, which is the ability to, in a fast way, low latency way, I guess what Quintus hinted at as well, like very important for DeFi, in a fast way, use the output of one piece of software as input of another one without having to have coordinated in the first place. So kind of the Linux CLI angle of having one very specialized tool to do the job, but in a way where it's very easy to combine 50 of such tools without them having to know about one another. And so at T1, my new startup, we are trying to solve exactly that, and we are trying to do so with trusted execution environments, enhanced with deterministic re-execution towards consensus and crypto economic security to back that up. I know consensus will be a big deal tonight. And reinforced further with zero-knowledge proofs in order to prevent an economic ceiling of the crypto economic stake.
Very interesting mixture of privacy-enhancing technologies that, in this context, actually can really aim to provide good usability to users. I would also like to ask Shresth, of course, for the introduction of his project, and of course, you can make it as extensive as Orest did.
Thanks, Orest. Thanks, Filip, for organizing this. I'm Shresth. I'm the CEO of Pod Network. I'm a builder by heart. You know, I started coding very early, then have been kind of early user of crypto. I started in DeFi, got into smart contracts, and kind of went down the stack, understood cryptography protocols. And during this journey, I kind of learned how it's quite difficult to build protocols that can compete with real-world applications. So building Web3 applications that have the UX of existing Web2 application. I mean, you go to Google, you type something, you press enter, and it's there. You don't even feel the reaction, right? While if you've used existing Web3 applications, you know how difficult it is, how many number of steps you have to do. And yeah,
no worries, no one uses them anyway.
But that's what we want to change, right? We want to build infrastructure that allows people to build applications that can scale to the internet size while also keeping the UX comparable. Because I feel that one of the key reasons why Web3 hasn't got that adoption that we want is like there is so much additional overhead and cost, while the benefits do not start to kind of compound over. So we need to get to that inflection point where it starts making sense. And I guess T1 is doing part of it with composability and using TEs to kind of speed run before even the cryptography hits. And Pod is taking a completely kind of new design, and we're going to talk more about it. But the way I like to think about it is, you know, if I'm paying for a coffee in Argentina, somebody paying for a coffee in US should not have to wait. And somehow today's blockchain, they synchronize everything, like everybody waits for everybody else. And of course, that will lead to queuing and make things slow. Yeah, and Pod is building this in an asynchronous way, and I'm happy to tell more about it later in the discussion.
Sounds great. So I think usability, I have heard multiple times. It's also part of the title. I will just be happy if you can align on what is your definition of usability. Feel free to start, whoever who wants.
Well, I guess one thing is user experience, UX. I'm not sure where the border to usability is, but I think what we align on is we are kind of eyeing.
You don't have to align. It can be,
It can be completely against that.
Yes.
So I guess what we care about,
Yeah.
and not just Shresth and me, but most people in the ecosystem, is to enable use cases such as paying for coffee on-chain. And clearly, there's certain benefits and certain drawbacks depending on how you structure this. One way could be universal synchronous composability. Every coffee payment is synchronously and atomically composable with every other one. This clearly will lead to huge delays and doesn't make any sense whatsoever. But this is something that seems to be very popular nowadays as a starting point because it makes DevX easier. Now, the other version that you can think of could be, well, let's make the UX better by having super low latency and by having some sort of maybe pre-authorization, like a Visa-like system. And there you could say, well, this is so much removed from the crypto ethers, and you have reversibility, and you don't know where consensus is, blah, blah, blah. And so I think what, again, Quintus, I think, hinted at, what level of latency is even perceivable to the human might be a good guidance to look for what a good user experience might be.
So one of the things that come to my mind immediately is, we say in our manifesto, we'll be successful when 1 billion people are using us without knowing it. And I feel like the success story of crypto is going to be when people don't know it's behind, the Web3 is behind. To be frankly, honest, it's a glorified database. It's a global database that everybody wants to talk to. And you don't really know what database does Facebook use or Google use or any of those applications. So the more hidden we are, the better we have done at building that UX. So the way I would think about it is if somebody in Nigeria opens a market and trades against somebody in China on the same level without them knowing at all about the frictions of addresses and onboarding and on-ramping and off-ramping and all of that stuff, it's completely hidden. You just go, you log in into the system, you start interacting with it as if you would interact with anything that's already out there and do much more than what you can do today, even in the UX. Everything else is just kind of hidden behind.
But unfortunately, trading is one of those use cases that actually do benefit and kind of require universal synchronous composability, because everyone's trade.
I feel like composability and the synchronous composability, as a technical terms, you and me understand. But from UX, it's really, if applications can talk to each other and do things, that's all it matters, right? It's not really up to the user to kind of feel whether it's synchronous or not, as long as the applications can kind of
the user cares about being able to buy the thing and being able to buy the thing cheaply.
Exactly.
And having those two is very difficult in a global way. This is why we have many markets and we have spreads and inefficiencies and delays. Right. Because this actually is a difficult thing.
Agreed. Systems don't talk to each other. Even traditional systems like payment systems, they are not composable. And that leads to a lot of fragmentation, right? All of the traditional systems, half of the thing is they don't interact. And Web3 is one of the key things it brings is this being able to just compose things together, right? You can start a lending protocol that composes with a DEX, which composes with a wallet, which composes with some derivative protocol on top, right?
Yeah, easy. So you get a token on Optimism, then you send a composable message via the L1 to actually use it on Scroll. And mere 7 days later, are you able to use your token on Scroll? Works, right? Not practical at all, though.
Sure.
Maybe on that aspect, I see very different type of use cases you always have in mind that are kind of driving your focus and your project. It'll be also interesting from what aspect of adoption, what are some of the use cases you really see that you can unlock with your solutions? And maybe how does it also later propagate into your product market fit with respect to finding some particular companies? Because from your side, it's a little bit sounds, Shresth, that you're actually maybe more focusing on traditional parties that actually are already out there, like more in the Web 2 direction. Whereas for Orest, it's like really focusing on this type of DeFi use cases that are very prominent with what am I hearing. We'll be happy to hear your take with respect to your go-to-market and what are some of the use cases you're really excited to unlock. Orest?
Yes, so for me, I am trying to not be this crypto OG kind of computer scientist liking nerding about long-term architectures, and I need to proactively look for it, and instead start from the user perspective. And indeed, one of the use cases nowadays that we are seeing is DeFi and stablecoins and earning yield and literally saving money. And so one go-to-market that I see in a world where you can have fast proving, like T-enabled real-time proving of existing L2s, and programmability, so not having to have one guy look at what's going on in the different chains and trust them with your funds, but having a programmable trust minimized manner. In a world that has this, that T1 is working towards, one use case would be Filip has 5,000 USDC. He trusts Aave on Optimism. He trusts Aave on Scroll. He trusts Aave on Base. And he just wants to get yield. And so he goes, opens up the three instances, looks at the APY 4, 5, and 6%, and goes with the 6% is, and forgets it. Now, how cool would it be if instead could Filip express that, or like use a product that lets him automatically move between the different Aave instances based on where the yield is higher, automatically without trusting someone not to rack him. This is something that real-time proving and programmability enable.
Super cool. For us, like the long-term vision is to put like as much of human coordination and trust as possible to like kind of trustless systems, or systems that are more kind of verifiable trust. But kind of backtracing from there, I think we have two kind of tiers of applications that we are targeting. One is kind of short-term in the next 6 months to a year, and some are like more like 5-year scale. On the 6 months to 1 year, our focus is really to show how our architecture, which is providing optimal latency, which means that if your network internet ping time is 100 milliseconds, your transaction is confirmed in 100 milliseconds. How this kind of super latency optimized infrastructure, what is the kind of return that you get, what is the UX that you get out of it. So kind of focusing more on the applications that can benefit from this low latency and high throughput. And
what are those?
Yes, so we are focused on 2 of those. So one is fast markets. As we had the last talk where we were talking about how time is translated basically into money in financial markets, we know that NASDAQ and all of these traditional stock exchanges are hyper optimized, and most of the price discovery happens there. And recently we've seen some of the order books moving on chain with Hyperliquid and so on. We want to show that anybody can launch these markets on chain, on pod, and while still having latencies which are as good as it can get, while still being fair and open. So when you trade on today's like stock market, you're always having a worse price than the trader that's sitting next to the trade market, next to the exchange. While with pod and markets running on pod, anybody across the world who has a good internet connection will have equal access while still the markets being fast enough. So this has just not been possible before, and I think we are quite excited about that.
Why isn't the floor the round trip around the world though? Like how can you have a globally, I guess, attractive latency versus a co-located, like data center co-located high-frequency trading box?
Yeah, so you could definitely have like a server running on a single machine and then have people co-locate there, but then you're trusting the server, and the server can just decide to not include your trades or include it in whatever order it wants to. And this is all we're fighting, right? We're fighting to build systems which are fair and open. And what that would mean is you have to kind of distribute this trust across a set of nodes which are geolocated, and then you want to find out what's the best you can do when you don't have a trust on a single machine. And basically, what pod does is you can have a geolocated node while your kind of latency to confirmation is bounded by the, let's say, the 2/3 slowest node in the network, which could be like 150 milliseconds.
So it's basically an alternative to, I guess, slowing down the market to the blink of an eye. Like, do you know that paper? Like slowing down high frequency to like frequent batching or something?
Exactly. We do a lot of batch auctions, and that allows us to build efficient market structures. But I don't know, maybe we're going out of time for this question, but I can keep. So the second thing, we're very focused on payments, and on the long term, we want to go into like governance, voting, and like other use cases that we have in mind. Yeah.
Sounds great. I think like a lot of interesting use cases to think about, because it still will enable the seamlessness, right, with respect to using your applications, your approaches. And I think we would like to a little bit dive into some of the technical components on actually how is this being unlocked. So from you, Shresth, we have here the aspect of consensus-less approach, very, very spicy when you look at it, because many of the current solutions always rely on consensus. And for you, Orest, we heard like a combination of TEs and ZK. So I'll be happy to actually hear what is some of the innovation and technology that actually you are using in your particular solutions that are enabling this future generation of solutions out there. Shresth, maybe?
Sounds good. Thank you. So if you look at kind of the evolution of blockchains, right, like starting from Bitcoin, it feels like we've just extrapolated. We took Bitcoin and we said, let's put an execution on top. Okay, the execution is slow. Oh, maybe the proof of work is taking a lot of energy. Let's replace it with something like proof of stake. And then, okay, what's the next problem? And we just kind of extrapolate from there. And for us, like, we were not looking to build a new network. We were looking to solve how to build auctions fast in a decentralized way. And then we realized that you could come up with an architecture where you don't need a lot of machinery that blockchains use today. In particular, you don't need to have this global synchronization, which we refer to as consensus. And we kind of went down this rabbit hole, and we came up with a very simple protocol that makes this trade-off of not having consensus. I want to just kind of give a little bit of overview of what consensus is to people who might be new to it. So you can think of blockchains and consensus today as like a pipe. And you have transactions coming in, and what it does is it orders every transaction. So every transaction gets an index. This is transaction 1, this is transaction 2, transaction 3, transaction 4, and so on. Now, if you have to order a lot of these transactions coming across the world, you will immediately have like a bottleneck. If you're a software engineer, you work on traditional databases and so on, you might have heard of locks. So if you acquire like a global lock to a table, like you acquire a global lock to a database, every transaction, it will definitely slow down. So it's quite common in the database literature that you should never do that, and it's obvious, but somehow blockchain world kind of...
they know better.
Yeah, exactly. we were taking back from there, and we said, let's just build a layer which doesn't do that. It doesn't mean you cannot have ordering, right? So this is maybe one of the misconceptions about our tech, which is the base layer doesn't provide any ordering, and this allows you to be very fast. And you can do a lot of applications like payments, auctions, without needing this order. But then the moment you need synchronization, you can build it on top. So you can almost think about like consensus protocol as smart contract on pod, which is kind of a little bit mind-boggling, but then it's like ordering is another kind of dimension of programmability that you get on pod, which allows you to control your MEV, allows applications to build like custom ordering gadgets that might be more optimized for their applications and so on. Yeah. So, for example, for the CLOB or order book stuff, market stuff that I was talking about, we don't do a FIFO queue. We don't do first in, first out. We do batch auctions, which you hinted on. And there again, the ordering in milliseconds does not matter. Only the set of orders matter. Yeah. So we've made this trade-off, and this has allowed us to achieve like hundreds of thousands of TPS on real systems. And we're quite excited to get something out and people to start playing with it.
Very cool. Yeah, at T1, our vision and our hypothesis is that synchronous composability be too expensive, too impractical in a world where there's big incumbent L2s. So we have Arbitrum 15B, Base 15B, TVL.
Can I ask you a question? I feel like you use the word synchronous composability, but you've not defined it. I feel like you have a definition. I know it because I've talked with you, but maybe you should like just give a hint on like what synchronous composability
So
is.
by synchronous, okay, composability, the ability to connect the output to an input without asking and coordinating upfront. Synchronous composability for me is when the output, like it's kind of like atomicity. Maybe you can simplify it that way. So in blockchain terms, it would mean that all of the ingredient transactions of such composable meta transaction are happening in one unit of time, and they also fail or succeed together. Whereas asynchronous composability would be working with callbacks, what we know from JavaScript or whatever. That is requesting that something happen on base, and upon this thing's success or failure, would some sort of callback be called with the output, and then would the second leg be called maybe on Arbitrum, and then another callback, and then the third leg on Scroll, whatever. Yes, so we believe that having synchrony in this composability paradigm is too impractical. First of all, for fundamental reasons, like first principles, we don't need, and it doesn't make sense to have the guy paying for coffee in Buenos Aires have synchrony with the guy paying for something somewhere else. But
So
second,
we're aligned on that.
we are, yeah. But second, we believe it to be impossible politically, because big L2s have the 15 billion, have the ecosystems, whatnot, and it just doesn't make sense for them to go the extra mile to allow interoperability and composability, especially with smaller chains. So we built for this world as it is, for the status quo, where we have those big L2s that do not opt in to give up the sequencing rights to one entity, which is a technical requirement for synchronous composability. If you want,
I would like to challenge that, but we could challenge it later.
So again, quick definition by give up, I mean if Arbitrum and Base are to be built synchronously such that a transaction either happen or fail together and that they all happen in the same unit of time, you have to have one entity have the ultimate sequencing power for that period.
My claim
And
is you
that
could have a
seems to be
consensus among the
infeasible.
two. You could have a consensus among the two, and that would work out, even if you don't have a single entity that runs it.
Well, I guess that's kind of what we have nowadays, right? We use the L1 as settlement, so the L2s build their own sequencing and then put it on the L1, and then we use the L1 to have composability. And it is indeed like composability, but it's just very slow.
Yes.
So in the status quo, we see this big pain point that the user needs to move between chains and change RPCs and bother about liquidity and trust people to move the assets, and even worse, to manage the assets in their stead if they don't want to manually have to open up the different wallets on different networks every day. And so in order to fix that, we run this special reinforced network of TEEs within which we are following the different sequences of the different rollups and allowing T1 users, which is developers, so allowing T1 dApps to request reads to be brought into them from the existing rollups, or also request writes to happen, request transactions to be put into those chains on a best effort basis. So based on a callback, which may fail or succeed. What you wanted to challenge me on 3 things, I think.
No, we can talk later. But I think you could. I've been thinking about this since your talk last time you gave it at Common Prefix offices, and like you could build like a consensus between the sequencers, and you could even run like consensus which can tolerate like up to n-1 failures under synchrony, and then you would be able to like not give up the sequencer right always, but then like just use it time and time just when you want to like do certain things which need but
Yes,
it
so I
might
think
end
what
up being it might end up being slowing down things. So I don't know. It's a
exactly.
design
So
choice.
this is basically the
It's a
trade-off,
design
right?
choice, yeah.
That you need to either have some sort of way of reaching consensus fast,
Yeah.
and if you don't trust one another,
Yeah.
you kind of want to have some sort of proof, for instance, a ZK proof.
Right.
This was the original roll-up roadmap.
Right.
Or you trust the other guy, then it's fine, right? Then
Right.
you can go fast.
Maybe.
Or maybe you can have something in between where there's this like super solid canonical bridge into DL1 that's
Yeah.
slow, and then there's some sort of economically capped system,
Yeah.
and that is where we see T1.
Nice.
Talking about trade-offs, actually, I think we are focusing on the usability from the user perspective, like to really make the mass adoption. But what about the poor developer in the middle that has to use your tools? Like, how do you make their life easier, and what are some of the challenges that you are actually, they think they have to solve? Because it sounds like also that you're actually offering them more opportunities on how to tweak their particular application for the needs, which also means actually they have to know much more details about how the system actually behaves.
Yeah.
So I'd be just like happy to also hear your take on how do you ensure usability from the developer perspective as well.
Sounds good.
Trust.
Sounds good.
Maybe we keep it slightly shorter.
Yes, yes, I will keep the time in mind. So I feel like building like good DevX is a difficult problem. It takes a lot of time. Ethereum spent like N years now to get to a point where it's like people actually understand how it works. I feel Ethereum and EVM and Solidity are kind of the JavaScript of this smart contract world. It's ugly. We know it's broken. It doesn't work, but people love it. People use it. So at least what we are trying to do is we're trying to be as close as possible. And that's what we call as EVMX. Our architecture itself doesn't constrain us to use any language, but we want to start with something that developers already know. Keep the interface JSON RPC very similar so that they feel like they're still in the same environment. Also, you get like MetaMask and all the wallets out of the box. So yeah, these are some of the steps we are taking to just make it easy for the developers, and maybe hopefully in future Ethereum EVM will mature, add more features, and the language will become less and less ugly. But for now, it's the JavaScript. We embrace it, and I think we love it, so it's fine.
Yeah, it's ugly. It's, I guess, the quality of this world. Like, it just doesn't make sense, but that's where we are. And now with for us, with asynchronous composability, that's even worse, because the developer needs to be unwinding things. It's annoying, and it's terrible, but it seems to be still the optimal trade-off to be making.
Yeah.
So what we can do is provide samples, provide documentation, provide education, and try and make things reusable. Try and basically build up on the EVM ecosystem, on the critical mass that there is, basically, and go a bit incrementally. Unfortunately,
yes.
Even though, like you say, it would be cool to start from first principles and then trash certain assumptions.
But we've seen some products trying first principle on the DevX and not working as well, right? We've seen with
Move,
Cardano,
right?
Move. I mean, they're trying a lot. Maybe it will pick up, but until then, it's going to be difficult.
Sounds great. So I think we have heard a great journey, a lot of future endeavors, and it seems like that you try to solve the underlying fundamental problems. DevX hopefully will come in the future because it's ugly, but it seems like that the trade-offs that led to building it as it is actually are not as bad. So thanks a lot, Orest. Thanks a lot, Shresth, for the great discussions, and looking forward to having you around again.
Thanks a lot, Filip. Thanks a lot, everybody, for organizing.